Hey everyone, this video is about the HP 48SX, an advanced graphing calculator that first came on the market in 1990, and it was really the synthesis of three previous lines of HP calculators. It took the software functionality of the HP 28C and S, the hardware functionality and customization of the 41 series, and the look and feel of HP's Pioneer calculators. And this was all integrated into a tall graphing calculator form factor that Casio had pioneered with its FX 7000G. The SX was the first of the 48 series of calculators that HP evolved for over a decade, and it added features that were really a great leap forward for calculators at the time. It was the first calculator to support a true textbook-style equation editor, a spreadsheet-style matrix editor, and support for units that was really deeply integrated. And on the hardware side, it evolved and modernized the extensibility of the 41 series. It had support for ROM and RAM cards and a RS-232 serial I/O, which at the time was becoming the standard way PCs communicated. It also supported an infrared port for communication with printers and other calculators. The SX also supported keyboard overlays and a user-definable keyboard, key feature of the 41C, and so you could really turn the SX into a custom device that worked for you. And the SX is such a beautiful device physically. It took the color scheme from HP's Pioneer series and created what some might say looks like the archetypal engineer's calculator. And it came along when PCs were still to reach their pinnacle of adoption and calculators were more relevant as professional tools than they are today. At the time, surveys of HP's high-end customers revealed that nearly all owned or had access to a personal computer, but they still used their calculator daily. And professionals made up half of the customers for HP's high-end technical calculators. And the 48SX, as well as being very beautiful, has exceptional industrial design. The overall design language is an extension of the Pioneer series, so the colors and design elements are the same as on this 32S2, for example. Of course, it is a lot thicker and has a more boxy look, but it was designed to be held in the hand. The top part of the case is injection molded plastic, and you can see the copper electroformed Hewlett-Packard logo. You might also be able to see this tiny arrow above the logo that is pointing to the location of the infrared port. And there's a thin printed aluminum overlay that cascades down over the keyboard. And this was to add durability and form part of the electrostatic discharge system. The display on the SX is 131 by 64 pixels, and it uses an STN LCD display, which in all honesty has very poor contrast. The displays on the SX can be very hard to use in low light situations, and the display was massively improved in later 48 series models. I'll include a link to my buddy Darren's video comparing 48 series displays in the video notes. But the keyboard on the 48SX is really excellent and similar to the Pioneer keyboards with two added rows. The keys were painstakingly designed by HP to have great tactile feel and for reliability, and it really shows. They have two cantilever beams and the keys are made of mylar plastic with graphite traces for added inertness and reliability. And the key labels on the SX are double injection molded, so they will never wear off. Some later 48 series calculators had printed key labels. And they slope downward slightly, as you can see on the side view. The top row are soft keys for navigating menus, and you can see some key labels have a subtle dark boxes around them, which indicate that they are for menus. And looking at the back of the calculator, we'll remove the top door to reveal the SX's I/O ports. So on the left you can see the 4-pin serial port, which was custom designed by HP since typical RS-232 ports were too large, and of course USB had yet to be developed. And so to communicate between your computer and an SX, you'll need this specific cable that was designed for the 48, and it's still possible to buy these online, or you could make one yourself. The SX uses the Kermit protocol for both its serial and infrared interfaces, and it is a bit fiddly to set up. You'll need to set the right baud rate, flow control, and data parity on both ends. But if you're old enough like me to remember dial-up modems, then you'll be familiar with these sorts of settings. And on the top right, you can see the infrared transmitter and receiver, and these supported a bunch of different use cases. So maybe the most useful is you can use it to print wirelessly to an HP 82240 printer, but it's also possible to wirelessly transfer data between two SXs, and you can even send data from a 41C or 28S to the 48SX. The SX can emulate the Wireless printer interface. And HP actually limited the receiving range to 2 inches because they were worried about students using it to cheat in exams, but the transmitter range is actually several feet, and there are programs available to use it, the 48SX as a remote TV control. The SX also has 2 expansion slots for credit card size ROM or RAM cards, and I don't have any, but they slide into these 2 grooves. And you can still buy RAM cards for the SX for a reasonable price made by a company called Retronic. And I'll include a link in the video description. And I'll talk later about some of the large range of commercial libraries that were available for the SX. And so returning to the back of the calculator, we can see, we can open the battery compartment, and you can see the 3 AAA batteries, and these last for around 400 hours of use. So the 48SX is held together with rivets, which makes them really hard to disassemble and even harder to get back together without damaging them. And personally, I think this was an unfortunate decision by HP. You can understand why a lower cost Pioneer might have been designed not to be easily repairable, but it's more difficult to justify with an expensive high-end engineer's calculator that costs the modern day equivalent of $600 in 1990. And so anyway, I'm not going to take mine apart, but here's an image of the top of the PCB from hpcalc.org. And so looking at the top left, we can see a Mitsubishi M5M 32K static RAM chip. Below this is an NEC 1880 chip that housed the ROM. And in the middle of the board, you can see the slots for the credit card sized library and RAM cards, which plug straight into the PCB. On the right side of the board, you can see 2 SCD 1181s, and these were CMOS dot matrix LCD controllers for the top and bottom halves of the display. And on the right in the middle, you can see the system on the chip that includes HP's own 3rd generation Saturn processor, the 2 MHz Clark version, and the Clark version of the Saturn supported dynamic expandability of memory based on those plugged-in ROM and RAM cards, and this was the Saturn processor that was last manufactured by HP. Later calculators used Saturn processors manufactured by NEC. And the system on the chip also includes a memory controller, a timer, and a collection of analog circuitry for the crystal oscillator and also the low power indicator. And on the right of the board, you can see the 4-pin serial interface and the infrared transmitter and receiver diodes. And the basic usage of the SX is similar to the 28S before it, and of course it uses RPN. So to calculate 2 to the power of 16, we would push 2 onto the stack and then enter 16 and then hit the Y to the power of X button. And the SX has an unlimited stack, so we don't need to keep track of the depth of calculations we're doing, and we also have a large history to select results from, so we can do that using the up arrow, and then we can pick a value from the stack to get added to the bottom. And to apply a function, we can just hit the key for that function. So say we wanted to find the sine of 45, we hit sine, or we could have typed the name of the function, so I'll enter 45 again, and then I'll enter sine using the alpha key, and then enter. And we could have also picked the function from menu if it's available. The SX also supports expressions in algebraic format, so to calculate that 2 to the power of 16, we could have entered 2 to the power of 16 in quotes and hit the eval key to evaluate it. And the SX, being an RPL calculator, supports a wide range of 17 data types on the stack. So for example, we can, if we take the square root of -1, we can see that the SX displays complex numbers in this tuple format. And it also supports vectors and matrices, strings, lists, and so on. The SX also has some simple CAS features that can perform operations on algebra expressions. So let's recall an expression onto the stack, 2 times x plus sine of x, and so we can square that by entering 2 and y to the x. And you can see that the SX has multiplied the terms together, and many of the SX's functions are available via a menu system which works in a similar way to the Pioneer series. And this might be the biggest learning curve of the SX, since there are many menus and all the functions have abbreviated names. So for example, there is an algebra menu, and we can use the next button to page through the options. But we need to remember what each abbreviated menu name refers to. And this is one aspect of the interface that HP tried to improve on in later 48 models, adding an option for more descriptive drop-down menus. But for me, there's a certain elegance in the SX's menu system, although it may not be the most user-friendly experience for new users. The SX also includes a directory system for variables. So we can see now that we are in our current working directory as the home directory. But if we go into vars, I've actually created a directory called D. So if we select that, we can see our current directory changes and there's no variables within that D directory. If we want to go back up to home, we just hit the up key. And we can see that the current path has changed again. And so directories were a great way to organize programs and variables in memory. So all the features I've shown so far work the same way on the 28C and S. And so now I'll talk about 3 features that were new, not just for HP, but for calculators in general. And the first new feature was the equation writer, which allowed for textbook-like display and editing of equations. And this was really a stunningly innovative feature in 1990. So we can enter the equation writer using the equation key. And so let's enter a sigma expression to sum n squared from n equals 1 to 50. And so we'll start by typing in sigma. And we can see that there's a box displayed below the sigma for the summation index. So let's enter alpha n. And now we can hit either the right or down arrow keys to select the next entry place. So I'll press down arrow and then hit 1 and then down arrow again and 50 and down arrow. And now we'll enter our expression to sum, so that's going to be n to the power of 2. And so now we can hit the enter key to leave the equation editor. And we can see that the equation's been added to the stack. And even with this simple example, we can see the linear format is not as immediately understandable as a textbook-like display. For complex cases, it can be difficult to mentally parse all the parentheses in equations and also remember the meaning and order of multiple function parameters. So say we wanted to edit this equation again, we can just hit the down key. And you can see that starting the equation editor with an existing equation can be very slow. But I'll exit out again, and we can hit the eval key to see the answer. And so this feature was really useful, and according to HP Journal, this type of equation editor wasn't even available on desktop PCs in 1990. There was typesetting software that could display equations in textbook format, but none that would allow direct editing and now what you see is what you get fashion. And HP really laboured over the UI design of the equation editor. The use of the arrow keys for equation navigation was very controversial internally. But modern calculators still have similar interface patterns for textbook-style equation entry, including the support to scroll vertically and horizontally around large equations, and similar ways to auto-match parentheses. And this really speaks to the thought that HP's designers and engineers put into the equation writer interface. And so the second new feature I'll talk about on the ESX was the matrix editor. In some ways this solved a similar problem as the equation editor, where vectors and matrices could be difficult to manipulate in a linear format. And so we can jump into the matrix editor using the matrix button, and it works pretty much how you would expect it to. You can use the cursor keys again to navigate around, and the editor auto-detects the matrix dimensions from the data you input. You can also calculate cell values using RPN, and matrices support complex numbers, so we can enter -1 again and square root, and the matrix editor will put a complex value in the vector. When we're done, we can just hit enter again, and we can see that that's been added to the stack. And I believe this was the first spreadsheet style matrix editor available on any calculator. Casio and Sharp's existing graphing calculators at the time did support matrices, but had more rudimentary line-by-line editors. And a third pioneering new feature of the ESX was its unit system. So previous calculators did support unit conversions, but with the ESX we can attach a unit to any value on the stack, and those units get tracked as arithmetic operations occur. So a very simple example is, say we wanted to enter the value of g, the acceleration of gravity on the surface of the Earth. Well, that's roughly 9.8 meters per second squared. And so let's enter 9.8, and we can select meters from the length menu. And we can now attach more units. So to divide by a unit, we just select it using the right shift key. So let's select the units menu again and pick the time menu, and we'll select seconds using the right shift twice. And so now we get our value in meters per second squared. And we can do calculations on this value, and new units will get calculated. So say if we square our value, we can see our new value is meters squared per second to the power of 4. And so units are deeply embedded in the calculation engine of the ESX, and if you're doing complex engineering calculations in particular, this can be incredibly useful. And the ESX supports also user-defined units, which is useful if you're working with units that are not natively supported by the calculator. And again, HP really thought through this feature well, and it really set up a model for units that was replicated by future advanced calculators. And as I mentioned, the Essex had a large range of library cards available. There were 3 published by HP. The most notable was the equation library card, and this included over 3,000 equations, and it's the equation library app that's built into later 48 series models, as well as the 49 and 50G. Another notable one was the 41CV emulator card that supported the ability to run programs that were written for the 41CV on the SX. It also provided a 41 keyboard emulation mode where the 48 keyboard and display were redefined to function as a 41CV. And it even came with a keyboard overlay to indicate the functions of the redefined keys. The last one I mentioned is the 48SX demonstration card, which was designed for stores to demonstrate functions on the 48SX. And I'll include a link in the video description to a video showing this running. But there are also many library cards published by third-party vendors. In particular, Sparcom published a series of cards in its Pocket Professional series that were the equivalents of a lot of HP's own 41 card packs aimed at professional users. There were ones around mathematics and engineering applications, flight navigation, and so on. And so the Essex has a very large selection of library cards available, but like the library packs for the 41, they tend to be fairly expensive to collect now. Prices of cards range from about $100 to $400 on eBay. The Essex was also an amazing platform for programming, and in this way it continued the legacy of the 41 series. And so the Essex supported simple user-defined functions, but its main programming environment was the user RPL programming language, which I won't go into depth here since I have a separate video on it. But it was also possible to program the Essex using lower level system RPL, which was the firmware of the Essex was largely programmed in and was effectively user RPL without runtime type checking. Also, it was possible to write code, of course, in Saturn assembler or in C using a cross compiler. And HP supported an MS-DOS application called the Program Development Link, or PDL, which allowed developers to create and test programs for the 48 series on their PC. And this all coincided with early growth of the internet. So many 48 series programs were distributed on Usenet in particular. And I'll talk about this more in future videos, but the community contributions to the 48 software eventually paved the way for software on future devices. And so the Essex in 1990 was a stunning device, and I didn't even cover so many features such as its solve function, its 2D graphing, or its ability to customize its menu or keyboard. And in terms of competing devices at the time, there was very little. Casio had its FX7700 power graphic device. TI only had its basic TI-81 graphing calculator designed for school kids, and Sharp had its EL9000. And it was really only with the TI-89 8 years later in 1998 that a competitor really released anything comparable to the 48. But from a modern point of view, the Essex wasn't without its flaws. For me, the two biggest ones are the display and the device speed. So the display on the Essex is really, without exaggeration, the poorest contrast of any calculator I've used. And it really is unusable in lower light conditions. Some of its interactive features, like the equation editor, can be frustratingly slow, pausing for more than 10 seconds during their operation. And just overall, the Essex does feel a little sluggish, especially if you're used to later RPL devices. The third weakness, which was evident by consumer feedback to HP, was its ease of use. So I do understand this to a certain degree. Often on the SX I bring up a menu and don't have any idea what the menu abbreviations mean. And all of these three issues HP did try to address with later 48 series devices. But overall, the SX is really a high point in the development of advanced scientific calculators. Aesthetically, it really is stunning, and I think it's one of the most beautiful calculators ever created. It was very much ahead of its time and pioneered features that became the standard for later advanced graphing calculators. And so I hope you've enjoyed this video and found it useful, and if you have, please don't forget to subscribe to the channel and hit the alert button to get notified of new videos. Also, if you have suggestions of calculators you'd like me to cover, please let me know in the comments.